Hello, students, and welcome back to Mechanical Engineering Practice and Graphics. Today we will be covering the chapter number 7 of the book, Advanced Modeling Tools 1. But first, I would like to go back to the schedule, uh, do a quick recap of what we have done so far. We're in week number 7, and we have done 4 homeworks so far. We already learned how to do renders last week. Also, we have completed the first midterm exam and the first quiz. This week on Thursday, we're going to have the second quiz. Um, and that's what we have done so far. This week, we also have the fifth homework. And regarding the final project, we started creating the groups last week. Some of you have already shared with me the contact information of your group, of the members in your group. Also, for this week, we're gonna do a quick draft, just from something handmade, the three standard views, front, top, and right, of the vehicle that you want to do for the final group. Uh, it's just for me to have knowledge of what you're aiming to do. Maybe you're aiming too high or too low, and I can provide some feedback on this. Next week, we're gonna have the spring break, which means there are no activities on next week. But once we come back, we will start working on the final project. Remember that each member must submit 5 parts for the final project. And in the last week of classes, I guess I have to modify the schedule due to the week that we lost in the winter storm. But still, in the last week, you will submit all the full package, which includes each part that you all have modeled in the project, the assembly file, putting all the parts together, and a couple of blueprints of the assembly that I explained in the last week's video. I will maybe talk about it a little bit more today. Also with the poster or the presentation that you have. Um, and that would be like the final submission of the final project. Remember also that there is a presentation on the week of April 26th to April 30. Probably we're gonna do those presentations on the Tuesday of that week. And that for this week, the draft is one submission per group. It's fine. And that's it. Uh, Please keep looking the schedule during the semester. Every week I'm posting this schedule with a mark showing where we are. And that's it for this week. Okay. Uh, for those of you that have not shared with me the contact information, I shared an Excel file last week. So if you go to Blackboard and you look in the week, we're in week 7. So if you go to week 6, you will find this Excel file. Just include the names, the phone numbers, the emails of the members in your group, and any platform that you are going to be using for contacting each other, either GroupMe, WhatsApp, WeChat, Line, Facebook, whatever you want. Since we have this remote teaching mode, we have to make some adjustments. Regarding this week's handmade draft, remember that it's handmade, just a couple of views. For example, this is a project from last semester. They did a boat. There were these 5 members, um, and that was enough. They had the real boat. They had the toy, so they were able to measure everything. Okay, I'm gonna mention again the final project rules for those of you that uh, didn't watch the last week's video. Um, it's a group project. All of you must work as a group. At the end, will be grading each other, and I will consider these grades for your final grade in the final project. So that's a way to ensure that everyone is working. Um, the groups must be a minimum of 4 members and maximum 6 members. Each member must do at least 5 parts for the group, SolidWorks parts, of course, and each part must have at least 3 different features. So the parts doesn't have to be very complicated, but no very simple either. Just uh, something that takes at least half an hour to do. Um, I'm okay for if you want to work with students from both sections, section 3 and 4. Just avoid having students from section 1, since I am only the TA of these 2 sections. Remember that in the final week, not in the final week, but the week before that, we're gonna have the presentations of the poster, or either just a couple of slides of your final project, including all of this information. Please showcase the final assembly that you do. This is the moment and place to to sell your design. And also, you will have a written report. There is a template in Blackboard. Um, I'm not sure if this is the correct location. I must check. But once I submit this set of slides to Blackboard, this will be fixed. Uh, the poster will be 50%. I'm going to be focusing on these 3 points. All the deliverables, part files for each member, the assembly files for the group, and the 2 blueprints that you must do using the assembly. Those in the final submission, that will be 25% of the grade, and the other 25% will be just the written report. Uh, it's a very easy report. It's just for you to get started in the writing activity, in how to present a formal report in college. Um, it would be helpful if you know how to compress folders, either zip files or RAR files. If you don't know how to either compress a folder or uncompress a folder, you can watch any of these video tutorials. These are of course for Windows users, Mac users, and Linux users. Um, it will be easier to submit everything together within the same folder. Besides, the SolidWorks blueprints and SolidWorks assembly files only work if the part file that it is referring to are within the same folder. So it's better if you have just everything together in the same folder and just submit everything together. Remember, if you are missing any required part, well, some points will be deducted. Okay, since the topic for today is advanced modeling tools, I'm gonna do 3 different tutorials today. This is gonna be one. This is not graded. This is going to be the second tutorial. Again, this is not graded. And the third tutorial is gonna be this T connection. Again, this is not graded. But with the tools that I will be using throughout these 3 tutorials, you should be able to do today's homework, which is gonna be this part. Actually, I have to change the date for this. It's gonna be March 7. And I will explain a little bit more about this homework once I do the 3 tutorials. So that's it. Let's begin. Okay, for this part, as we have here, We have the top view with some section here. As you see, we can see like what it's the bottom like. And then we have this line, this dotted or this continuous line AA, which is marking a section view. Here in the front view, we don't have the front view, we have the section view. It's like if we take a knife and cut this part through this line, and then we turn it over, we will see a, a solid material only what it's marked with these parallel lines, with these diagonal parallel lines. So these are just a detail that gives us more information about this part. So to begin, I'm gonna open SolidWorks. And using the front plane, I'm gonna create a new sketch. As usual, I like to begin by having lines for construction in the center. Actually, I'm gonna delete this one. And then I can take advantage of the symmetry plane of this figure. As you see, it is symmetric. I can divide this figure right and left, and it will be just the same. So I'm gonna just model one half, and then I'm gonna use the mirror entities to complete the other half. So I will start with this front view, or this section view. Then here we have 208 millimeters from side to side. So I'm gonna go and select the Smart Dimension tool, this line in the center, and then this corner here. And then I'm gonna move the mouse here to the left in order to have the full distance from here on the left to here on the right. Then we have here this angle of 106 degrees from the horizontal. So I can use the horizontal and the diagonal line to define this angle. Then I'm gonna draw this vertical line here. For this height, the total height here is 14 millimeters. So I'm gonna define that height. And then we have 68 for this height here. Then I don't have the distance from this edge to the center, but remember that this edge is actually this point here because we're cutting this solid here. And this cut, as you see, is actually a circle around here. I can actually draw that circle. And you will see that maybe I'm gonna do dash line. You will see that that circle there is actually marking both edges, which is given by this radius here of 54 millimeters. So I can use that to define this distance, 54 millimeters. Okay. Then we have this 56 here in the inside, like that. Then we have a vertical distance of 16. So this vertical distance is 16. I can still move this point around because then we have this uh, arc here of 24. So we can define that. As you see, the center of this arc is a little bit below this horizontal line. It's actually 4 millimeters below. So I have to do a second line here of 4 millimeters. And then I can use this tangent arc tool, the second option in the arc, to define an arc that is tangent to this vertical line, and then that goes all the way here. Now, this is the center of this arc, and this center should be aligned with this vertical line and with this point here. So I'm gonna add a relation there between the center of the arc and this line. They both are coincident. And then I can define, of course, this is already defined, but let's see if I can add that relation there between those 2 points, setting that they both are horizontal. As you see, this sketch is fully defined. I can now use the mirror entities. Then I'm gonna select all of this, excepting this line here. Use this contour, and then I'm gonna select for the mirror axis, the center line, and then click OK. We have a closed loop, which I can now extrude. So I'm gonna go to exit sketch. I'm gonna go to features. I'm gonna select extrude boss base. And then here, I'm gonna select the sketch that I just did. I can increase this depth like that, or here, using the tools on the left. However, in this case, I want, well, first, it is gonna be 46 millimeters. So let's define that dimension there. But I want that the front plane goes through the center of that geometry. So instead of doing the blind extrusion, I'm gonna select the mid-plane extrusion. Here we have a couple of different options. You just have to get familiar with those. We can also have multiple directions. So if, for example, I select direction 1 blind, I can activate the second direction. And I have a second direction extrusion. But in this case, I just want it mid-plane. Then I'm gonna select OK. And we have that geometry there. Now, in the bottom, I'm gonna draw a big square like that. Also, I'm gonna draw these 2 squares here, and this circle here, and this circle here, and these oval shapes here on the left and on the right. So using the face in the bottom, I'm gonna create a new sketch. I press Ctrl 8 in my keyboard to ensure that I'm in perpendicular to the plane, so I can draw in that plane. And as usual, I'm gonna start by having here lines for construction. And then I'm gonna draw first the big square. For that square, I'm gonna use the second option here on the squares that is called the center rectangle, all the way there. And then we have that the width is 195 and the height it's 35, like that. Now I'm gonna do this square here on the right. Um, as you see here, we have this dimension that is saying that we have two squares with sides equal to 28 millimeters. So I'm gonna draw just one square here. This side is 28. And we can add the relation here that this side and this side are equal in length. Okay, now we have to define the position, which is at 78 from the other side. So using the Smart Dimension tool, I'm gonna select the center, then this axis in the center, and the other side is 78, like that. Using that same center, we have this circle here with diameter equal to 12. So using the same center, just a circle with a diameter of 12. And finally, we have this oval shape here and here. We can find those here. It's called the straight slot. We have two arcs and then join with these two straight lines. So I'm gonna do first one center of arc, then the second center of the arc, and then the radius of those arcs. We have that this dimension here is 12. So let's go ahead and define that here. We have the distance between centers is 8. This one is 8. And then we have that the distance from the inner center to the inner center of the other slot at the other side is 154 millimeters. I'm gonna drag this one here. Again, as you already know, the figure is symmetric, so I can just copy these operations at the other side using the mirror entities. So for this one, I'm going to select the circle, the square, and the slot. And for the mirror, I just select the line in the center, and that's it. Now I can exit this sketch, and we have those geometries there in the bottom. Now, the big square is actually a cut inside the material. with a height of only 2 millimeters. So we can go ahead and click in the extrude cut. Then I'm gonna select the sketch 2. And here I'm gonna select, as you see, I can select uh, the brown or red color that we have on the screen is highlighting the contour that is gonna create the cut within the material. So I'm gonna select this portion here and then only 2 millimeters. Just to make sure, I rotate the part. I see that it's cutting inside. Sometimes it can create the cut outwards, and then we wouldn't cut anything. So we just have to make sure that we're using the correct direction. We just click OK, and you see that we have that cut within the material. Then I can use the same sketch to create more cuts. So for example, we're gonna create the cut of the slots at both sides. So I click that sketch that was under the first cut, only the sketch, and then extrude cut. Here I'm gonna select the slots, and actually I'm gonna use also the circles. Because this cut, I want to make it through all. So I will cut all the material that we have available in the model so far. Now I'll create this slot here and this slot here. And then we have those two cylinders inside the material. To make sure that I'm doing this okay, I'm gonna activate these planes, and then using the front plane, I'm gonna create a section view. You can see now how those cylinders are cutting the entire material and those slots are cutting just this part of the material. I'm gonna deactivate it now. And then I'm gonna do the last cut, that is these squares, using the same sketch that we did before. Just go to extrude cut and select those two squares. This time the cut goes 10 millimeters plus this 2 millimeters here, so it's actually 12 millimeters. Inside the material, and that's it. Can activate the plane again, sorry, the section view, and we have that section over there. We're almost done. We just have to do one more cut, but this cut would be actually a revolution, or we can do like a circle here in this face and cut upwards. So actually I'm gonna do both just to show you what I'm trying to say here. Using this face, I will create a new sketch, Ctrl+8, and then we know that we have a cut that is equivalent to this circle, but then I need to cut outwards. So I can just create a second circle that is bigger. And then I can exit that sketch, use extrude cut to the other direction, and click through all. That will make this trick, as you see here. That's one way of on producing this curve face here. Or I'm gonna do the other way as well. I'm just gonna delete this operation and this sketch, and I can actually use the front plane to create that cut. Control 8. And what I'm gonna do is I'm gonna create a rectangle using this corner and just making it bigger than this side, like that. I can exit this sketch. Sorry, I should have done something additional there. I'm gonna edit that sketch real quick, Control 8, and I'm gonna add a center line here, vertical and infinite length. And this time I'm gonna create a revolve cut using that sketch. And the line will be this line for construction that I draw in the center, and then a full revolution, and it will produce exactly the same as you see. Either way is equivalent. Um, all I'm missing now is this fillet here and the chamfers within the slots in the top and in the bottom. As you see, we have here a mark that is showing us that we have chamfers in the slots in the top surface, and that we have here this fillet of radius equal 8. So I'm gonna start with the fillet. Here under features, I go to fillet, the first option, and then I click here. The fillet is radius 8. I'm gonna modify this one to 8. And also this other line here. And then I can click OK. Finally, under fillet, in the deployable menu, we have the option called chamfer. These chamfers are only 1 millimeter at 45 degrees. So here we have 45 degrees, only 1 millimeter. And they go in this face or edge and in this edge over here. And then click OK. And that's our final product for this part. Now I'm gonna create a new part for the second tutorial. And in this tutorial, so in the first tutorial, we explore the, the advantages of having a symmetric part and only modeling one half. We learn how to do extrusions and to cut extrusions, and also how to extrude or cut a revolution. We also did the fillet here and the chamfers in the two slots. And using one single sketch, how to produce several cuts within the material. Also, we learned how to have a viewing section, as we did in this section AA. For this second tutorial, we have actually the same. We have a section AA here, that is this front view. We have the right view and we have the top view. And okay, yeah, that's it. So in this tutorial, I'm gonna select the front plane to create a new sketch. Again, my lines for construction, infinite, going through the center. And the first thing that I'm gonna do here is actually I'm gonna just draw this axis here that is going through this pipe. So this is an arc of radius 90, and I'm gonna place my origin here in this point. So I'm gonna select the center point arc. I'm gonna draw this arc like this with radius equal 90. And then we have a vertical line and then an horizontal line here. So this vertical line and then a horizontal line here. Now, the vertical distance from the edge of that line to the center of this other line here is 175. So this distance from here to here is 175. And then we have that the distance from here to here is this 145 plus this 25, which is 170. Actually, in the equation, you can write 145 plus 25, and it will do the math for you. And that's it for this sketch. So far I have just a line. I'm gonna activate the planes just to have them here. And then what I'm gonna do is I'm gonna create a auxiliary plane that the first reference is the right plane. This one is gonna be parallel to the right plane, and my second reference is gonna be this point here, and then it's gonna be coincident to that point. So with those two, this plane is defined, and I can just click OK. I'm gonna deactivate those planes. And using this auxiliary plane, I'm gonna create a new sketch. In this sketch, I'm gonna use this point as the center of an arc or of a circle, sorry. So I'm gonna create use the convert entities tool to create a shadow from this line. Okay. Maybe this arc. Okay. I guess I will just have to use my geometric references to know the position of this point here. So I'm gonna just draw a circle somewhere. And this circle is, we know that the distance from this center to this line is 90, and then we know this vertical distance is 175, so we can do the subtraction. From the center or the origin to the center of the circle is gonna be 175 minus 90 of the arc. Actually, this is wrong. It's actually only the radius, which is 90, the vertical distance from the origin to this center here. So this one is actually 90. And that's it. Now, the outer diameter of this is 97. That will be the diameter of this circle, 97. And then we have an inner circle or inner diameter that is 65 here in the top. So I just have to create a second circle there of 65 millimeters. I can exit this sketch now. And then I'm gonna go to features and select the swept boss base. And in this first option, I'm gonna select the second sketch that I did. And in the second option, I'm gonna select the first sketch. And then I can click OK. So that's how I have that pipe there. I'm gonna hide this auxiliary plane now. And then we can create these attachments on the top and on the right. So first one, the one in the top, I just go and select sketch in that face, Control 8. I can select the convert entities here to create these two circles, or at least this circle. This one is actually going to be for construction because all I want from that circle is the center. From that center, I can create the outer circle. And actually, I should create this inner circle too. The outer circle is going to be 225 millimeters. And then we have another circle here that is for construction. So I'm going to click here in the options for construction. And that circle is going to be this one with diameter 185. Then we have this circle here that is 20.5 in diameter. So actually I'm gonna create, just 20.5. This circle already has the relation of coincidency between the center of the circle and this other circle for construction. But now I want to add a second relation between this point and this point. Both of them are vertical. And now I'm going to create a circular pattern. So I go to linear sketch pattern. In the second option, we have the circular pattern. Here I select the geometry. And actually, no, I clear this and select this center here. In entities to pattern, I select the circle. And then in this case, we have 8 of these circles equally spaced in an entire revolution, 360 degrees. Then we can just click OK. And then that's it. I can just exit this sketch and create an extrusion using that sketch that I just created to the opposite direction, and the distance is 25. 25 millimeters in extrusion. So we have that top part there. I can do the same in this other face. I'm gonna create another sketch here. Again, I'm gonna use the convert entities tool to define the circle. And then define the outer circle, 225. Then the circle for construction with diameter 185. And then a circle somewhere. These circles are 20 and a half as well. And I'm gonna add the relation between this point and this point. They both are vertical. And then the relation between this point and this circle for construction, they both are coincident. And now we can do the circular pattern. Here I select the circles, and in this I clear the selection and select this point here. Again, it's 8 of those circles. We can exit the sketch now and create an extrusion to the opposite direction of 25 millimeters as well. We're almost done with this. We're missing this back part here. So what I'm gonna do is I'm gonna create another auxiliary plane here at 240 from this face. An auxiliary plane from this face parallel at 240, but at the other direction. So I'm gonna flip the offset and then okay. Gonna activate my planes. And using this plane, we can create other sketch here. Again, we know that this center line is at 90 from the origin because here is my origin, in this point here. So I'm gonna add a center line there. This line is at 90 from the origin. And then a couple of circles here. These two are coincident. And the same goes for the other line, the vertical line. First, I'm gonna start with the outer diameter, the one that is 50 millimeters. And then actually I'm gonna just leave it that way. Or no, let's do the 3 circles there. 24 and then 20 in diameter. This one is 24 and the other one is only 20. And then we can exit this sketch. Now in this sketch, I'm gonna use the extrude boss using just actually everything. And in this one, what I'm gonna do is actually I'm gonna select up to next um, or up to surface, and then I select this surface. So I will just create the extrusion from these circles to this curve uh, face. Okay, and then using that same sketch, I'm gonna create an extrude cut using the same sketch, but this time I'm gonna just go with the inside and this part to the other direction. This one goes only 28, so this one is 28. And then using that same sketch, I create a last cut, this time only the inner circle. I change the direction, and this time I'm gonna go through all. So we'll cut up to here. So if I create now the section view using the front plane, we will see this cut inside the material, that it's right here, as you can see. So that's it for our second tutorial today, and the third and last tutorial. This is actually the most complex part, but okay. A quick review from this part was we learned how to use the swept boss base to do the pipe. We began by doing just the root of the circular extrusion that we did. So the extrusion doesn't have to be straight lines. We can also do extrusions in curvilinear paths, and that's what we just did. Then in those two phases, we did a couple of extrusions with holes, and in those extrusions, we learned how to use the convert entities tool and the circular pattern tool as well to create these uh, holes or patterns around the centers. Finally, we also learned how to use auxiliary planes to create this sketch here and also these uh, circles here that we use to create these geometries in this part. Remember that from the beginning, I was using this point as the origin. So that's the good thing of being aware where your origin is all the time. It, it helped us a lot during this tutorial. Okay, now the last part, it's pretty similar. It's just a couple of revolutions with some holes inside, but it's essentially the same. So I'm gonna create a new file, and then in this geometry again we have a section view. This AA line here, we have the section view in the front, and then we have just the right side in what is called the view BB. Um, that's pretty much what we have here. Okay, now using the front plane, I'm gonna create a new sketch. As usual, my lines for construction. and then the vertical one. And now I'm gonna just draw the the side on the left here. So um, I'm gonna start by adding a, let me see. I'm gonna start by adding this exterior here and then the inside. Now in this drawing, I'm seeing that all these lines for construction are uh, intercepting each other here. So this is gonna be uh, my origin in the center of these two lines, also here. Okay, the vertical distance that we have from the origin to the bottom down of the or this face in the bottom, it's 100 millimeters. So I'm gonna start by adding another line for construction there, somewhere here, and this distance is 100 millimeters. Okay. Then we have this inner diameter here, which is 72. That will be like our starting point. This one is 72. That will be this point here. And then we have this big diameter in the bottom that is 190. And then we have here 12 millimeters, the vertical direction. And then it goes up to this diameter here of 100. Then it goes up until we hit 26. Here. And then this diameter is 130. And then we have a vertical displacement. This one is at the reported at the other side. It's only 50. This 50 here. So this distance here it's 50. And then we have this 150 to the left. And this one goes all the way up to 150 in the vertical as well. So this distance here is 150. Then to the right at 125, um, and then to the left and up. Now we have this 185 from the bottom to the top, 185. And also we have this height here, only 12 millimeters. That will define this position. And then we have this diameter, which is also 190. Actually, I'm gonna use the correct one. From there, we just go down and right, down and right. This diameter is 105. Then we have the height of 5 millimeters. And then this inner diameter, it's 95 millimeters. And then we go down until we hit 135. And then we grow until we hit 105 millimeters. This point actually goes down. So this one is 105. 105. Here we have a fillet of radius 2. Right here. I guess up here as well. Well, it's only one, so the other one shouldn't be. 2 millimeters here. I'm gonna move this one around. We have this vertical distance of 135, so I'm gonna define that one using this line and the one in the bottom. And then we have here to the right and then down. This vertical distance is 63. And then the diameter here is 87. This diameter. and then it goes like this. But this height is 46, like that. We have two chamfers at 45 degrees, or sorry, no, this is a chamfer of 2 millimeters at 45 degrees in the bottom. So here will be a chamfer of 2 millimeters here, like that. And then we should have also a fillet here. I'm gonna assume that that fillet is also radius equal to, like that. So I have this geometry, it's fully defined, and then we can do that revolution. So I'm gonna exit the sketch, create a revolution using this axis here, and we have that revolution over there. Okay, then we have um, another revolution in the same face, but using the horizontal line. So what I'm gonna do is actually use the front plane to create a section view, and then using the front plane I'm gonna create a new sketch. This time the line for construction goes this way, another vertical here, and then we have the distance from the center to this face is 155. 155, okay. Like that. All right, I'm gonna do for this one, I guess, let's see. Let's begin with the top part. First, we have a circle of 160, so that will define this part here. This diameter would be the 160. And then this one grows 12 millimeters to the left, and then down. This one is 12 millimeters. Then it goes up to 80 millimeters. So this one here it's 80 millimeters. And it goes 64 from this edge, as we have here, 64. So this distance here is 64. And then it goes up a little bit and then to the left. The up is now 90. So this diameter here is 90. And we have a diameter of 150 here. Okay. And then it should just go down and to the left. Okay, that's like this. And then I can just click this point, shift in my keyboard, the other point, and merge them. But I still need to define the inner diameter, which is 60 millimeters. I can exit this sketch, create a revolution using this axis here, and then deactivate the section view. We have this. Now, as you see here, this face is not connected to this face. We have a gap here, so we have to close that. The easiest way I can think of is if we create just a sketch there. I'm going to create a new sketch, and then we use the convert entities tool to define this circle and that circle there. Since we have those two circles, then we can exit the sketch and click the extrusion. And in this case, we can select either up to next or up to surface and then select the surface. Both are equivalent. So since I already showed to you how to use the up to surface, I'm gonna use this time up to next. And that's it. We have that closed there. If we activate the section here, we will notice that this hole, now it has a barrier here from the first revolution. So what I'm gonna do is I'm gonna just extrude this circle up to this inner surface. So I'm gonna create in this face another sketch. I'm gonna select the convert entities tool, but only for this circle. And then I'm gonna exit this sketch. Now I'm gonna use the extrude cut tool, and this time I'm gonna select the up to surface, and I'm gonna select this inner surface, and then click OK. If we verify the section now, we will see that now the two holes are connected. Now I need to do these circular patterns here in the top and in the bottom face, and we should be done. So using this face, I'm gonna create a new sketch. I'm gonna start by using the circle for construction. And the circle has a diameter of 125 millimeters. And then we have the circle in the bottom perfectly aligned, diameter 12. This one is 12. And then I'm going to add the relation between this center and this point here. They both are vertical. And now I can select the circular pattern. Here in the entities to pattern, I select the circle. In the point, it's already selected the correct point, so I don't have to do it. Then this time it's 6. I can exit this sketch, create a cut, and this time up to next. And that's it. We have those holes there. Here in the top, I'm gonna select create a sketch, Control 8. Same thing, pretty much. This circle is for construction. The diameter of that circle is 150. And then we have that the circle this time is aligned to the line on the right. So I'm going to start with this circle here of diameter 15. As you see, this circle is already coincident to the circle for construction and horizontal to the origin. So I can just do the pattern. Again, it's 6 of the circles. Then I extrude the cut up to next. That's it. And then in this phase, we do the same. A circle for construction. That is actually the same. And as you see here in the top view, we have the circles, like dark circles, that are in the top face. But then there is a mismatch from the circles in the bottom face. The circles in the bottom are aligned with the vertical line, not the horizontal. That's why we have some of those circles with hidden lines. That's why here in the section view, that is cutting the material through this line, we only see the holes here in the top, but not in the bottom. So we have to take that into account. That means that this circle is not aligned here in the right, but here in the bottom. And that they are with actually bigger diameter, 17 instead of 15 of the ones in the top. So this one is 17. As you see, it already has the two relations that I need, so I can just proceed with the circular pattern. Again, only 6 of those. Exit the sketch, extrude the cut in the up to next. And that will complete this tutorial. As we see, this is exactly what I was saying. We have the holes in the top part because the section only cuts those holes, but not in the bottom because there is a mismatch. So if we change the view of this with hidden lines, and then we use I guess it's Control 5, the top view, we will see that only the holes that are in the top are dark, but then the ones that are in the bottom are with hidden lines. Okay, so in this tutorial we learned how to do, well, this was a very intricate revolutions, but then in the extrusions we learned how to use the up to surface and up to next options. Also how to do patterns for those small holes in those faces. Um, and we learn also how to use the convert entities to close this gap here. As you remember, there was this gap here, and we closed it with just an extrusion. And then we did all those holes. Also how we connected this hole here with this other hole here, resulting in this curve here. And that was it for this tutorial. Okay, now the homework. Um, it is important here to know that uh, we have this 3 degrees angle coming from a line in the center of this arc. This is an arc, and the vertical line. There are 3 degrees, and that this arc should be tangent to these lines. Now, as you see, these lines are not horizontal. They are actually at 3 degrees from the horizontal line. So they are diagonal lines. All of those are parallel here. This is just 5 millimeters from this edge to this inner edge. We have this section view for this point here. That is highlighting the fact that this part here has these arcs, these circular holes. Also, we have chamfers coming through this loop, 1.5 millimeters at 45 degrees chamfers at both sides, in the top and in the bottom. And the same for this circular or cylinder here, in the top and in the bottom. We have those chamfers. Um, I guess with all the operations that I showed today, you should be able to replicate this geometry. Again, this is due for next Sunday midnight. And remember that on Thursday, we're gonna have the second quiz. As usual, I will make available the blueprint at first minute of the day, and you will have the entire day to finish it. And also, please remember, for those of you that doesn't have a group or haven't shared the contact information, please do so. And remember that this week you should submit the quick draft, one per group. And I think that's it for today, guys. Thank you for watching this tutorial. Uh, Hope you enjoyed and learned a few things. Good luck with the quiz this week. Enjoy next week's spring break, and see you, I guess, in 2 weeks. Bye bye.